In this Cc3 problem, we're trying to solve this trig equation. But what's confusing about the equation is that there's two trig functions, both cosine and sine. You always want to get your trig equations down to just one basic trig function. So I see that I can use a trig identity to substitute in for sine squared. Instead of sine squared, it's going to be 1 minus cosine squared x. So now I have 2 plus cosine x plus equals 2 minus 2 cosine squared x. So now I have a cosine squared and a cosine, which to me looks quadratic. I'm going to move these two terms to this side so I can get my equation equal to 0. So that's 2 cosine squared x plus cosine x, and if I subtract the 2's, they cancel, equals 0. Now, this is a quadratic. It might be hard to see based on the cosines, so I'm going to let u equal cosine x. So now I have 2u squared plus u equals 0. Much easier to play with. I'm going to factor out a GCF of u, and that leaves u times 2u plus 1 equals 0. U equals 0 or 2u plus 1 equals 0. So u equals 0 or u equals negative 1/2. So remember that we defined u to be cosine x. So cosine x equals 0 or cosine x equals negative 1/2. So to solve for an angle, we do inverse trig. So when we do inverse trig, there's always more than one answer. So for 0, we're asking, where does cosine equal 0? So cosine and sine are zeros only on our quadrant angles. This point is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. Remember, when you're looking at the unit circle, x is cosine, y is sine. So where is cosine equal to 0? It's equal to 0 at 90 degrees and at 270 degrees. Here, cosine inverse of negative 1/2. Now I'm trying to think about, where is cosine negative? All students take calculus. Well, cosine is positive here and here, so therefore it must be negative either here or here. So here are our two sample triangles. What are these possible angles? Where does cosine equal 1/2? Well, I know cosine is 1/2 for 60 degrees. So this angle is 180 minus 60, which is 120, and 180 plus 60 is 240 degrees. So these are our possible x values. Now, if we're being super strict on cosine inverse, the restriction of that domain is from 0 to pi. So that would actually be only 90 or 120, but you can write all four to be safe. In example 10, now we have sine of 2x equals cosine x. Once again, we have an equation that has both sine and cosine. It's confusing. I need a trig identity that can help us simplify this. Well, sine 2x is 2 sine x. Cosine x equals cosine x. So now I will divide this cosine x to the side, and these cancel. So now I have 2 sine x equals 1. Divide by 2. Sine x is 1/2. Or x is sine inverse of 1/2. So now where does that happen? All students take calculus. We want a positive sign. Positive sign happens here or here. What angle could this be if sine is 1/2? That's 30. So 180 minus 30 is 150 or 30 degrees. So with solving trig equations, use trig identities to help you get down to one trig function, and then do inverse trig to find the angle using all students take calculus to find the correct quadrants.